Hello dear students, welcome to a new math class. Today we'll be talking about the two conjugate numbers. For a and b two non-negative, the two numbers square root of a plus square root of b and square root of a minus root b are conjugate. So what are the two conjugate numbers? They are the two same expressions except for the middle sign. So root a plus root b, its conjugate will be root a minus root b. Root a minus root b, its conjugate will be root a plus root b. They're two same expressions except for the middle sign. One is positive, the other one is negative, and vice versa. Okay, how about the sum of the two conjugate numbers? Root a plus root b plus root a minus root b, it's 2 root a. The product of two conjugate numbers, like for example root a plus root b multiplied by root a minus root b, that's the difference between two squares, then it is root a squared minus root b squared, then root a squared is a minus root b squared is b. So the product of the two conjugate numbers is a minus b. Note that the product of the two conjugate numbers is always a rational number. Let's move on to the first example and see how are we going to solve it. This question, the question is asking us to make the denominator of each of the following as a rational number. So the question is asking me to rationalize the denominator. How are we going to rationalize the denominator? By multiplying up and down by the conjugate of the denominator. So for question number 1, the denominator is root 7 minus root 5. What is the conjugate of root 7 minus root 5? Yes, it's the same expression with an opposite middle sign. So we're going to multiply up and down by root 7 plus root 5. Let's solve it together. So as we said, we're going to multiply this by the conjugate of the denominator, root 7 plus root 5 up and down. So it will be 2 multiplied by root 7 plus root 5 divided by, we said that the product of the conjugates is the first one squared minus the second one squared. So root 7 times root 7 is 7 minus root 5 times root 5 is 5. So it's 2 times root 7 plus root 5 over 7 minus 5 is 2. The 2 divided by 2 are crossed out together, so the answer here is root 7 plus root 5. Question number 2, we're going to multiply up and down by the conjugate of the denominator. So we're going to multiply up and down by 2 plus root 3. So here in this one, square root of 3 multiplied by 2 plus root 3 over 2 squared, which is 4, minus root 3 times root 3 is 3. So it will be 2 root 3 plus 3 over 1, which is 2 root 3 plus 3. Example number 2. If x is 5 over root 7 minus root 2 and y is root 7 minus root 2, the first requirement is to prove that x and y are conjugate numbers. How are we going to do this one? Yes, we're going to work on x first. X equals 5 over root 7 minus root 2. We're going now to rationalize the denominator of x by multiplying x by its conjugate. So it's 5 times root 7 plus root 2 over the product of these two conjugate numbers is 7 minus 2. If you simplify it more, it's 5 times root 7 plus root 2 over 5. Then it is root 7 plus root 2. If x is root 7 plus root 2 and y is root 7 minus root 2, then for sure x and y are conjugate. Requirement number 2, to find the value of x plus y all squared. How can we find the sum squared? So x plus y all squared equals, what is the sum? Yes, excellent. Here is x, root 7 plus root 2, as we got it from here, plus root 7 minus root 2 all squared. As we said before, that the sum of the two conjugate numbers is 2 square root of a. You will see here that these two roots are crossed out together, then it's 2 square root of a, which is square root of 7 all squared, right? So this power of 2 will go above the 2 and will go on the root, right? So it's 2 squared times root 7 squared. So it's 4 times 7 is 28. Example number 3, if x equals 3 over root 5 minus root 2 and y is root 5 minus root 2, the first requirement is to prove that x and y are conjugate. And the second requirement is to find the value of x minus 2xy plus y squared. Let's work on the first requirement first. How to prove that x and y are conjugate numbers? We're going to work on x. So x equals 3 over root 5 minus root 2. Let's rationalize the denominator by multiplying up and down by the conjugate of this denominator, root 5 plus root 2. So it's 3 times root 5 plus root 2 over 5 minus 2. 5 minus 2 in the denominator is 3. So 3 times root 5 plus root 2 over 3 is root 5 plus root 2. So x is equal to root 5 plus root 2, and y is given as root 5 minus root 2. Then definitely x and y are conjugate. And this is what the question wants me to prove. The second part, if the question wants me to find the value of x squared minus 2xy plus y squared. So as you can see here, x squared minus 2xy plus y squared is the simplified part of x minus y all squared. So let's find x minus y all squared. The x is root 5 plus root 2 minus the y, which is root 5 minus root 2, and this is all squared. If you simplify the part inside the bracket, root 5 plus root 2 minus root 5 plus root 2 all squared. The root 5 minus root 5 is 0. Then it's 2 root 2 all squared. If you make this to the power of 2, it will be 4 times 2, which is 8. Let's now move to another type of question, which is complete each of the following. Question 1. Root 7 plus root 3 multiplied by root 7 minus root 3. Here's the product of the two conjugate, right? Yes. How can we do it? It would be 7 minus 3. it will be the first one squared minus the second one squared. So root 7 minus root 7 is 7, minus root 3 times root 3 is 3, so it is 4. Question 2, the conjugate number of 1 plus 7 over root 7 in the simplest form. The conjugate number of this one is 1 minus 7 over root 7. And then we need to rationalize the denominator, so it's 1 minus 7 over root 7, and we multiply up and down by 7, and we multiply up and down by root 7. Then it's 1 minus 7 root 7 over 7. The two 7s are crossed out together, so it's 1 minus square root of 7. How can we find the conjugate of the number 1 over square root of 3 minus square root of 2? Yes, from what we just did in the previous questions, you will see that the 1 over root 3 minus root 2, we're going to rationalize the denominator by multiplying it by the conjugate of the denominator. Then it will be root 3 plus root 2 over 3 minus 2. So it's root 3 plus root 2 over 1. Then it's root 3 plus root 2. Take care, this is not the conjugate, this is the value of this fraction. So let's find the conjugate of this fraction. It will be root 3 minus root 2. Question 4. If x equals 2 plus root 5 and y is the conjugate of x, then what is x minus y all squared? As long as y is the conjugate of x, then y equals 2 minus root 5. So the x is 2 plus root 5 minus the y, which is 2 minus root 5, all squared. This will be 2 plus root 5 minus 2 plus root 5 all squared. Then this one is 2 square root of 5 all squared. Then the answer is 2 squared, which is 4, times root 5 squared is 5. So the final answer is 20. Question 5. The multiplicative inverse for this one. The multiplicative inverse is the reciprocal. So it is the flipping. So the multiplicative inverse of this one is 1 over root 3 plus root 2. They want it in the simplest form, so we need to rationalize the denominator by multiplying up and down by its reciprocal. Sorry, by multiplying up and down by the conjugate of the denominator. So it's root 3 minus root 2 over 3 minus 2, which is root 3 minus root 2 over 1. Then the simplest form is root 3 minus root 2. Question 6. Root 2 plus root 3 all to the power of negative 9 multiplied by root 2 minus root 3 all to the power of negative 9. This can be written as root 2 plus root 3 times root 2 minus root 3 all to the power of negative 9. Let's find the product of the conjugate first. The product of the conjugate will be 2 minus 3, and then you can put the power negative 9. So it's negative 1 to the power of negative 9. Then the final answer is negative 1. We came now to the evaluation part. As I always tell you, dear students, please pause the video, try to answer the question yourself, and then play the video again to check your understanding and also to check the final answers that you have got. Let's now go and see how are we going to solve this problem. Here we have x and y given. The first part of the question, they want us to prove that x and y are conjugates. So let's prove that they are conjugates by working on x by rationalizing the denominator of x. So 4 over root 7 minus root 3. How are we going to rationalize the denominator? Yes, excellent. By multiplying up and down by the conjugate of this denominator. So it will be 4 times root 7 plus root 3 over 7 minus 3, which is 4 over root 7 plus root 3 over 4. If you simplify it more, the two 4's will be crossed out together. Then the final answer will be root 7 plus root 3. So x equals root 7 plus root 3, where y is root 7 minus root 3. So now, for sure, x and y are conjugates. Let's now move to the second part of the question, which is to find the values of x minus y all squared and x squared minus 2xy plus y squared. Let's first find x minus y all squared. We found x in the proving part, so x was root 7 plus root 3 minus the y, which is root 7 minus root 3 all squared. To simplify this, it's root 7 plus root 3 minus root 7 plus root 3 all squared. Then square root of 7 minus square root of 7 is 0. Then here, root 3 plus root 3 is 2 root 3 all squared. Then 2 squared is 4. Root 3 squared is 3. Then this one is 12. The second part, the question wants us to find x squared minus 2xy plus y squared. That's the second part. Then if you can see here, x squared minus 2xy plus y squared is the same as x minus y all squared. And we already got x minus y all squared in the previous part. So x minus y all squared is 12 as we found it in the previous step. By solving the evaluation part, we came to the end of our session. Thank you very much, dear students, and wishing you best of luck.